Welcome to this lesson. Once again, we are still going to use the first principle method in differentiation to prove the product rule, or how functions that are multiplying each other can be differentiated. So watch or follow me as we go into this proof. First, let's recall in our limit or using the first principle, we have limit as our age approaching 0. So as our age approaching 0 of the function at what x plus h minus the function at x all divided by h. So in this one, we are also going to do the same thing for this one, where we are going to get my dy dx is going to be equal to our function limit as our h approaching 0 of the function f of x plus h multiplying what? My g of x plus h, multiplying my g of x plus h, all minus this minus my function at x, multiplying the g also at x. This is also g at x. Mind you, everything is over h, so all of this is multiplied by 1 over h. This is also multiplied. So the whole of this is multiplied by 1 over h. But let's see what we can do over here. We can introduce a concept of 0, where whenever I have, for example, whenever I have minus f of x plus h multiplying my g of x, and I add it to the same thing, f of x plus h multiplying my g of x. When I add this is just 0. So when I add 0 to this, I've still not changed the function. The function still remain the same. So I can equally add it to it. Now if I add it to it, how would the function now look like? Our new function will now be limit as h approaching 0 of our f of x plus h multiply my g of x, plus h, all minus the same thing, all minus my f of x multiplying my g of x. Now here we are now adding the whole of this, guys. So adding that, we are going to get minus f of x plus h multiplying my g of x plus my f of x plus h multiplying my g of x. Okay, now that we have this, okay, so this is actually x and this guy is also x over here. Okay, mind you, everything is over h, so we need to repeat that while we put everything over h over here. Sorry, everything is multiplying what? 1 over h, so multiplying 1 over h. So here we can rearrange the terms over here. We can rearrange the terms where we are going to have this term first. We are going to have f of x plus g of x plus h, f of x plus h plus g of x plus h, where that is going to give us, we are still following dy dx, so here it is still dy dx, where here is also what? My dy dx is going to be equal to my limit as h approaching 0. Up here we are now having f of x plus h multiplying what? Our g of x plus h, okay. Now we are bringing what? These guys here. We are bringing these guys here. Or better still, yes, we are bringing these guys here. Where we are going to have this is minus the whole of this, which is what? Our f of x plus h multiplying g of x over here. Then we can also group the same thing for this one. Now we have made use of this, also made use of this. So we are now left with this and this. So in that, I can now say plus my, okay, this is going to be plus my the whole of this guy, which is what? F of x plus h multiply my g of x minus here. So this is going to be, okay, we have made use of this, so minus this, minus my f of x multiply my g of x, All right, then we know that everything is divided by h. So the whole of this is still divided by h, multiplied by 1 over h. So over here, we can now take the limit of the separate function. For example, when you have limit as maybe a approaching 0 of f of a plus f, okay, maybe g of a, this limit is the same as limit as my a approaching 0 of my f of a plus my same limit as a approaching 0 of my g of a is still the same. So we are using that concept over here, where we are going to break these guys into two. We take the limit of this part, then take the limit of this separate part. Mind you, each of the section will surely still be divided by h. Okay. So in that, what is going to be our separate limits? Then we still have that my dy dx is going to be equal to limit as my h approaching 0 of the whole of these guys, which is going to give me f of x plus h multiplying what? My g of x plus h. My g of x plus h. This is minus my f of x plus h, my f of x plus h multiplying my g of x. Alright? And mind you, all of this guys too is over h. So the whole of this guy too is over h. Alright? Now we can now also take the separate limit of here, limit as h approaching 0 of whatever is here as well, where we are going to have f of x plus h multiply my g of x. This is minus f of x. This is minus my f of x multiply my g of x over here. So this my g of x is going to be g of x. Mind you, everything is divided by what? H over here. So here as well, we are going to have this and this 1 over h. Okay. So what is common over here? You can realize that f of x plus h and f of x plus h is common. So we can factor that out. But when we factor that out, we are going to get f of x plus h. Alright? But let's see, as h is approaching 0, what will this guy become? As h is approaching 0, we limit as h is approaching 0, this now becomes what? Only our f of x. Because our h now here has turned to 0. So we just have what? F of x. So we are now going to factor what? Our f of x out. So when we factor our f of x out, we are going to just get our f of x over here like this. Now f of x, now we have limit as our h approaching 0 of what? G of x plus h. So that is now going to give me what? My g of x plus h, my g of x plus h minus this is left with here g of x. Mind you, everything is over h. Here too is over h. Okay. So what does this tell you? The whole of this guy is what? The derivative of this guy. The derivative of this guy is the derivative of this guy. So it means that here we are finally getting our function of at x multiplying the derivative of this one, which is what? Our g prime of x. So here we now have our g prime of x. Let's see what the next one will also give us. So here, let's see what is common over here as well. G of x is also common here. So we can factor out g of x here. So when we factor out g of x, we are now going to be left with limit as our h approaching 0, where we are going to get what? F of x plus h. We're going to get our f of x plus h, our f of x plus h, then left with what? Minus f of x over here. Don't forget everything over here too is also divided by h. But what can we realize? We can deduce that we have g of x over here, right? So here I now bring what? My g of x. And the whole of this guy is what? The f prime of x. The whole of that guy, this guy is f prime of x. So this now becomes what? Becomes f prime of x. So this has now deduced what? our product rule, which is stating that, let's take out this guy. We are going to get finally our dy dx is going to be the function of x, the function at x, multiplying with the first derivative of the function plus g of x multiplying with f prime of x. So this is our product rule. So follow me. Whilst next we move into using this, the first principal method, to see how we solve functions in a form of a chain rule, or we are going to prove the chain rule. Thank you.